So number one needs you to graph this quadratic equation, and what you need to notice first is that this quadratic equation is in standard form. Standard form looks like that: y equals ax squared plus bx plus c, where that would make the a value equal to -1 for our equation. The b value would be 4, and the c value would be 1. So once you know your a, b, and c value from the standard form, the first thing you're going to do to graph this parabola is use the formula. So this is a big step. Use the formula x equals -b over 2a, which is the formula for something called the axis of symmetry. And so plugging in the b value and the a value, that's ultimately going to get you what? -4 over -2 to be +2. So your axis of symmetry ends up being x equals 2. Now on your graph, the axis of symmetry is essentially a vertical line that goes right down the middle of your parabola. So essentially that means it's going to be going right through your vertex. So there's your axis of symmetry at x equals 2. And the vertex is going to be somewhere on there. In fact, you can almost say, so the vertex is 2 comma, I don't know yet, but it's somewhere on there, 2 comma something. Well, the next thing we can do is figure out what the y-coordinate of our vertex is going to be. And we can do that by simply plugging in 2, the axis of symmetry, into the original equation. So this would become -2 squared plus 4 times 2 plus 1. Keeping in mind that this negative symbol, this negative sign, was way out in front. We're not squaring this negative, we're squaring x, and the negative sign is kind of hanging out in front. So this would become a -4 if we were doing some just baby steps at a time. And so -4 plus 8 should be 4, plus 1 is 5. So down here, that means that our full vertex is 2 comma 1, 2, 3, 4, 5. So that's actually where our vertex is, 2 comma 5. Now it's time to draw the rest of the parabola, and does it curl down, does it curl up? So what we're going to do next is figure out at least 2 other points. So it's time to figure out these 2 points. 2 other points. The vertex is a point, and we're going to figure out 2 other points by plugging in something else. We're not going to plug in 2 because that was the vertex, but if we can figure out something very simple, something else to plug in and get like another point, think about that. What have I said in class about what's easy to plug in? Like, what's the easiest, most ideal value to plug into the original equation? And I hope you realize that it would be 0. So -0 squared, if you want to do that, plus 4 times 0 plus 1. That's so quick to figure out that it's going to equal 1 when you plug in 0. So that means that one other point ends up being 0 comma 1. This is just algebra and graphing in general. When you plug in 0 for x, y will equal 1. So over on the graph, that means that 0, 1 is also on your parabola. It's essentially the y-intercept. And look, if that's a point and parabolas are symmetrical, then wouldn't there be another point directly across from the axis of symmetry? And there's a third point. So what's the coordinates there? 4, 1. And so there's two other points. And there's plenty of other ones. I mean, those are just two. And so now we can kind of sketch our parabola as, best you can. So it looks like this parabola is upside down, which, if you know the big picture with quadratic equations, okay, it's no surprise that it was going to be upside down because of that negative sign out in front of the x squared. As far as max and min goes, all right, if the parabola is upside down, then it has an absolute highest point, an absolute highest value. It's going to go down forever, so there's not an absolute lowest point, but there is an absolute highest point right here. So there's an absolute maximum point. And what is that maximum value? How high does this parabola go? How high or whatever is that point? 1, 2, 3, 4, 5. Which is essentially the y-coordinate of the vertex. So it has a maximum value of 5. Moving on to number 2. For this one, this equation is in a form called vertex form, And vertex form looks like this, where h, k is the vertex, and the a value, okay, determines, like if it's negative, the parabola is going to be upside down, and other than that, the a value determines if there's any kind of like vertical stretching when you compare it to the basic graph of y equals x squared. Okay? So, in this case, looking at my h value, x minus h, so my h value turns out to be negative 3. As if this were to say minus a negative 3. So that means our h value is negative 3. Looking at putting together our vertex. And the plus k over here, looks like our k value is going to be negative 2. So negative 3, negative 2, there's my vertex. Okay, there's my vertex. Which you don't need to like literally think about how it, like what the values of vertex form are, I guess. You could just look at this the way we talked about in class and go, oh, when you compare this equation to this equation, if I see a plus 3 in the bubble here, that is going to move it left 3. It's going to be a horizontal shift of going left 3, and this number, added onto the equation when you compare it to this equation, this would shift, our vertex, our entire parabola from here down 2. So this parabola has a vertex at 0, 0, as you should know, but this plus 3 inserted into the equation moves it left 3, and this minus 2 inserted at the end of the equation moves it down 2. And, this equation has a normal way it curls up, okay? But this 2, this a value of 2 being here, that sort of changes the way our parabola curls up. So watch this very carefully, how normally, and look, I'm going to erase the points I make here in a second. So the points I'm going to make here are not the final points. Normally, you know, the y equals x squared equation curls up like this. We go out 1, up 1. Normally we go out 2, up 4 in both directions here. So we go out 2, up 4. And then normally we go out 3, up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is like the normal way that this original parabola would kind of like curl up in the U shape. But, so again, out 1, up 1, out 2, up 4, out 3, up 9. But this a value of 2 stretches it vertically by a factor of 2. And here's what that means. When we go out 1, we're going to now go up 2. We're stretching it by a factor of 2. And when we go out 2, normally we would have went out up 4, but now we're going to go up 8. 1, 2, 3, 4, 5, 6, 7, 8. So we're going up like double because we're stretching it by a factor of 2. And if we were going to go out 3, you know, where normally we'd go up 9, we're going to go up 18, but, you know, we're a little bit out of bounds here, technically. So, and then just kind of quickly sketching my parabola. So there's the sketch of the parabola based on the h value, the k value, and the a value, and which makes, I mean, I graphed 4 other points, but we could talk about, let's see here, -2, 0, is that right? -2, 0, and another one would be -4, 0. You could have also talked about what, -1, 1, 2, 3, 4, 5, 6. You know, -1, 6 would have worked. -5, is that right? 1, 2, 3, 4, 5. -5, 6 would have worked. And look, if you want to do what we did in the first problem by like, well, can I just plug in 0? Yeah, you could. If you were to just plug in 0, this would become 3 squared, so that's 9. 2 times 9 is, what, 18? Let me double check this. So 0 plus 3, 9, so we'd get 16, right? And so, look, if you want to go with 0, 16, that would be fine. That would be fine. And by the way, our axis of symmetry, you can figure that out after graphing. You don't need to do it right away in this case, you know, if what you're dealing with is vertex form. You could figure that out now. So what's our axis of symmetry? It looks like it's going to be x equals -3. And when we look at, yeah, that was a max. So where that was a max, this would have an absolute lowest value, so that would be a min. So we're talking about a minimum value of what? How low is this minimum value? And it is -2. Again, this is essentially going to be your x coordinate of your vertex. This is going to be the y coordinate of your vertex. And that's how you do number 2. Number 3, the directions for number 3 and 4 and 5, just say factor. Just factor. Not solve for x. These aren't even equations. So solving for x would not make any sense because it's not an equation. So we're just going to factor. And so an overall review of factoring, or at least a quick review of factoring. There's 2 major methods of factoring. We got factoring out of GCF, and we got what a lot of teachers call unfoil, which is factoring into 2 bubbles. Okay? And the first method you should always try first is GCF. And if there is a GCF, you should factor that out first as a general rule. So number 3, is there a GCF? No. So if this is going to factor at all, it's going to be by unfoil or, making a couple of bubbles. So in this case, this is where if the bubbles are going to start off with X and X, that makes it pretty quick and simple to make your bubbles. And to do that, as a review, you want to think about the two numbers that multiply to get negative 40, but they also add up to positive 3. Two numbers that multiply to get negative 40, but they add up to positive 3. The fact that it's a negative 40 definitely matters, and the fact that it's a positive 3 definitely matters. So, some people have to write this kind of thing down, But so here's my advice. You definitely want to start with making your numbers, like coming up with your ideas coming from like the negative 40, And again, if you have to write all that stuff down, that's what you got to do. And start off systematically, like, well, negative 1 and positive 40, negative 1 and positive 40, that's a possibility to get my negative 40, but does that add up to positive 3? Nope. Don't forget that don't forget that you switch the signs there, positive 1 and negative 40. That's also a possibility to get negative 40, but those do not add up to positive 3. You move on to like 2 and 20, 1's plus, 1's minus, to see if that works. But eventually, and it hopefully doesn't take you forever, but you just got to be patient and not give up so easily. Hopefully you figure out that it actually is plus 8 minus 5. Okay? That's the answer. X plus 8, X minus 5. Moving on to number 4, you got to check to see if there's a GCF, which there is. What's the GCF with 2x squared and minus 32? It's 2. And with a GCF, we divide it out of both the terms out in front of a bubble, and we put what's left over from dividing it out in the bubble. So, again, we're like pretty much undistributing a 2. And so what's left over? We got x squared here minus 16. So there's factoring by GCF. But here's the thing. You always need to check to see if this bubble factor can be factored some more. Sometimes it can't. Sometimes this bubble that's left over can't be factored more. But in this case, it can. So how can x squared minus 16 factor some more? Well, there's certainly not another GCF. We already did that. So can this unfoil into two bubbles? And it turns out yes. And you could think of this as, look, it's a binomial. There's only two terms, Normally, things that unfoil look like this. There's 3 terms. It goes x squared term, an x term, and then a number constant. So normally there's 3 terms. So listen, if something like this has any hope of unfoiling into two bubbles, it's got to be what a lot of people call a difference of two squares, or a difference of two perfect squares. And when you have that, your bubbles end up looking like that. The square root of the x squared starts the bubbles, and the square root of the 16 ends each bubble, with one bubble having a plus and one bubble having a minus. All right, I guess the only other thing to say and make this extra thorough is that if you want to think of binomials like this that could potentially unfoil, if you want to think of the middle term, the x term, as being 0x, because it kind of is, then you can do that. And then you can think of it as being, well, I'll write this down actually, no problem. If you want to think of it as literally being x squared plus 0x minus 16, and from there think about how, well, what two numbers multiply to make negative 16, but they also add up to 0, and think, well, negative 4 and positive 4, then you can do that. You can do that. But that's the final answer no matter how you sort of think your way through it. Okay? Now number 5, you look at this and you think to yourself, is there a GCF to factor out? And you look at all the 3 terms and you think, no, there's no GCF. And so if this is going to factor, we're going to go with unfoiling, like factoring into 2 bubbles. But here's the thing, as you might have heard me say in class, of course, okay? When there's a number out in front of the x squared other than 1, okay? This one was very simple to make your bubbles because it was just 1x squared, and so the bubbles started off with that. But when there's a number out here other than 1, it complicates things, and I pretty much emphasize you should do this method called the Phoenix method. And the Phoenix method goes like this. You multiply 3 to the negative 2. So you basically take that 3, which we're going to be calling the Phoenix, because that's the thing causing all the problems in the first place. So you take the 3 and you multiply it to the other end of the trinomial, the last number. And 3 times negative 2 is negative 6. That's the first step of the Phoenix method. The second step is to unfoil it into 2 easy bubbles, because now that it's just x squared, making your 2 bubbles is pretty easy now. So what's 2 numbers that multiply to make negative 6, but they add up to what numbers right here? What number's there? That's right, negative 1. So what 2 numbers multiply to get negative 6, but they also add up to negative 1, I'll even write it there. And you should get negative 3 and positive 2 eventually, or quickly you think of those 2 numbers. And so the next step in the Phoenix method is now to bring the Phoenix back to life. The Phoenix rises from the ashes. It was killed at first, and now it's going to rise from the ashes by being divided back in like that. So remember, first we killed the Phoenix, and then we factored the easier guy, and now we're going to bring the Phoenix, this 3, back to life. And the final step of the Phoenix method, or a couple of steps I guess, is to take these 2 fractions, reduce the fractions if you can, any of the fractions that can be reduced, you do so. So it looks like this is going to just become x minus 1. But this fraction could not be simplified or reduced. And so when that happens, you take this denominator and you literally move it up in front of that x. And so your final answer, your final 2 bubbles, is that. And we're going to finish the rest of this sample test on another video.